Hey my dear lovely students, a very good morning to all of you. Once again, I am in front of you for the live video session of the next topic of integers, that is properties of subtraction of integer. One thing worth mentioning, I could not take your last class on Tuesday due to some school work, so I really apologize for that. But in today's live video session, we will start on with the properties of integers for subtraction. Study sincerely and stay at home. Properties of subtraction of integer. Properties of subtraction of integer. The first property which we are going to discuss in this particular topic is closure property. As you all remember, in the last class we also studied this property for addition of integer, but in this particular topic we are going to study this for subtraction of integer. What is closure property? Suppose we take any two integer A and B. Suppose we take any two integers A and B. We are taking any two integers A and B. A can be of any value and B can also be of any value. Then the difference of two integers is always an integer. What does closure property suggest? Closure property suggests that if the difference of any two integers is always an integer, then this follow closure property. This can be applicable for any two integers. Here we have taken two integers as A and B. Let's see. Let A is equal to 5 and B is equal to 4. If the difference of two integers is always an integer, that is A minus B. A is 5 and B is 4. 5 minus 4 will be equal to 1. This 5 is a positive integer, this 4 is a positive integer, and the difference of both the integer is 1, and this 1 is itself a positive integer. Then what does closure property say? The difference of any two integer is always an integer. As we can see that 5 is positive integer. This 4 is also a positive integer. And the difference of both of these integer is 1. That is also an integer. And what type of integer is it? It is a positive integer. This can be true for any number. Let A is equal to minus 3 and B is equal to minus 2. Then again, the difference of any two integer is always an integer. A and B. A minus B. We can substitute the values of A and B respectively. A is equal to minus 3 minus B equal to minus 2. As I taught you in the last class that the two signs cannot fit together, so we put a bracket over here. This will be equal to minus 3 minus minus plus 2. Minus 3 plus 2 will be equal to minus 1. Hence, what we can observe, that minus 3 was a negative integer, minus 2 was a negative integer, and the difference of both of these integers is minus 1, which is also a negative integer. In fact, first of all, it is an integer. Then what does closure property suggest? If the difference of any two integer is always an integer. Is it clear, everyone? Let's move on to the second property, that is commutative law. That is commutative law for subtraction of integer. Commutative law for subtraction of integer. In the last class, we discussed this particular commutative law for addition, and in this class, we will discuss this commutative law for subtraction of integer. What is commutative law for subtraction of integer? Both are same in addition and subtraction. In addition, what we studied, that a plus b is equal to b plus a. But in this particular subtraction, in subtraction, this plus sign will change into minus sign. That is, a minus b is equal to b minus a. But this is not true. A minus b is not equal to b minus a, as subtraction of integer is not commutative. Subtraction of integer is not commutative. Let us prove this particular thing. Let two integers be a and b, where a is equal to 5 and b is equal to 3. Then first of all, a minus b. Let us take LHS, that is a minus b, and RHS, that is b minus a. A minus b, a is equal to 5, b is equal to 3, minus 3. 5 minus 3 is equal to 2. RHS, b minus a, b is equal to 3, minus a is equal to 5. 3 minus 5 is equal to minus 2. What we can observe? This 2 is a positive integer and this 2 is a negative integer, and both are not same. Thus we can write LHS is not equal to RHS. Hence, a minus b is not equal to b minus a. Thus we can say that the subtraction of integer is not commutative. Let us take one more example. Let a is equal to minus 3 and b is equal to minus 2. Again, LHS, that is a minus b, and RHS, that is b minus a. In place of a, we can write minus 3, minus, in place of b, we can write minus 2. But I taught you last class that two signs will not be together, so we'll put a small bracket over here and then the curly bracket. We can solve this. Minus 3 minus minus plus 2. Minus 3 plus 2 is equal to minus 1. Let's solve RHS. B minus a. B will be minus 2 minus, and a will be minus 3. Minus 2 minus minus plus 3. 3 minus 2 will be equal to 1. What we can observe? This is a negative integer, that is negative of 1, and this is 1, that is positive of 1. And since LHS is not equal to RHS, this implies that a minus b is not equal to b minus a. Hence subtraction of integer is not commutative. Let's move on with the third property, that is associative law. That is associative law for subtraction of integer. Law for subtraction of integer. What we studied in the addition of integer? In the addition of integer, that a plus b plus c is equal to a plus b plus c. This particular law for associative law we studied in addition of integer. In subtraction, a, the plus will change into minus, a minus b minus c is equal to a minus b minus c. But a minus b minus c is not equal to a minus b minus c, as subtraction of integers is not associative. In addition of integer, we had commutative law and associative law, and both were true for addition of integer. But in subtraction, both commutative and associative law are not true for subtraction of integer. Let's understand this with an example. Let us take three integers. Let us take three integers a, b and c, where a is equal to 5, b is equal to 4 and c is equal to 3. Then first of all we will solve LHS. Yes, that is a minus b minus c, a minus b minus c, and then RHS, that is a minus b minus c. A is equal to 5 minus b is equal to 4 minus c is equal to 3. 5 minus 4, we are left on with 1, then minus 3. 1 minus 3 is equal to minus 2. When we will solve RHS, a is equal to 5 minus b is equal to 4 minus c is equal to 3. 5 minus 4 minus 3 is equal to 1. 5 minus 1 is equal to 4. What we can see, that in LHS we have minus 2, in RHS we have plus 4, and both the LHS and RHS are not equal. Thus we can say that LHS is not equal to RHS, that is a minus b minus c is not equal to a minus b minus c. Hence, subtraction of integer is not associative. Let us understand this with one more example. Let a is equal to minus 2, b is equal to minus 3, c is equal to minus 4. The same condition. In LHS, we will take a minus b minus c. In RHS, we will take a minus b minus c. A will be equal to minus 2 minus b will be equal to minus 3. We'll put a bracket over here and then a curly bracket. Minus c is equal to minus 4. Remember one thing very clearly, is that whenever we get two signs together, we put a bracket over there. Curly bracket, minus 2 minus minus plus 3, close curly bracket, minus minus plus 4. Minus 2 plus 3 will be equal to 1. 3 subtracted 2 will be equal to 1 plus 4. What will we get? 5. Let's solve RHS. A, in place of A we will write minus 2, minus, in place of B we will write minus 3, minus, and C we will write minus 4. Minus 2, minus, minus 3, minus minus plus 4. Minus 2, 4 subtracted 3, we are left with 1. Minus 2 and minus 1 will be equal to minus 3. Once again, if you want to check, you can. In place of A, we have written minus 2. then minus, in place of B we wrote minus 3, minus, in place of C we wrote minus 4, minus 2, minus, minus 3, minus minus plus 4, 4 subtracted 3, we are left with 1, minus 2, minus plus minus, minus 2 and minus 1 will be equal to minus 3. Thus we can easily see that LHS is not equal to RHS. LHS is not equal to RHS. Thus A minus B minus C is not equal to A minus B minus C. Hence subtraction of integer is not associated. I hope you get it right. This was all regarding the properties of subtraction of integer. Now let us solve few questions regarding addition and subtraction of integer. Kindly pay attention and solve these questions in your notebook. Questions on addition and subtraction of integer. Let's move on to first question. We have to evaluate, that is we have to solve 53 plus minus 26. A very simple question. On solving any question regarding integer, the first thing which is most important is to take care of sign, whether it will be of a positive sign or negative sign. That is the first most important thing. When we solve this type of question, 53 plus minus 26. 53 minus 26. This is a very easy question. We can solve. 3 will not subtract 6, will take on carry. 13 minus 6 will be equal to 7. 1 we have given. 4 minus 2 will be equal to 27. 27 will be the answer. And we can easily conclude 53 and 26. Which one was greater? 53. जो भी नंबर बड़ा होगा हमेशा साइन उसका होगा. This rule is applicable only we have two numbers. Remember it. 53 and 26. 53 is the greater number, so we will have a plus sign over here. Let's take one more example. Minus 36, minus 44, minus 36 plus minus 44 and plus 90. Plus 90. In this particular question, we have 90 greater 44 and then 36. But in this particular question, we cannot say that the answer will be positive since 90 is greater. First of all, we will convert this particular question in two terms. That is minus 36 plus minus 44 plus 90. 6 and 4, 10, 0, carry 1, 4, 3, 7 plus 1, 80. That is minus 80 and plus 90. Which one is greater? 90. 90 minus 80 will be equal to 10. Is it clear, everyone? Now let's move on to the next question. Find the sum of minus 2035 and 297. We have to find the sum of minus 2035 and 297. This is a very easy question. I hope you all can solve it. We will write minus 2035 plus 297. Since we have to find the sum of the given numbers, we can easily solve minus 2035 plus 297. We will subtract 297 from 2035 and the sign will be negative because 2035 is the greater number. And as I said earlier, the number which is greater, its sign will be retained in the result section. 5 will not subtract 7. We will take on carry, that is 1. 15 minus 7 will be equal to 8. 2 will not subtract 9. We will take on carry 1, that is 12 minus 9 will be equal to 3. Here we had got 1 carry. We are left on with 9. 9 will not subtract. 9 will subtract 2. We will get on 7 and 1. That is minus 173. Let's move on to next question. The one question in which most of the students make it wrong. The question is subtract 27 from the sum of 50 and minus 10. Let's take a very easy equation. We have to subtract 27 from the sum of 50 and minus 10. So what is our first priority? We will first find the sum. We will first find the sum of 50 and minus 10. That is 50 plus minus 10. 50 plus minus 10. 50 minus 10, we are left on with 40. Now we have to subtract 27. Now we have to subtract 27 from the sum of, इन दोनों का सम कितना आ गया 40. अब इस 40 में से कितना subtract करना है 27. तो we can write 40 minus 27. How much will be the answer? 13. Is it clear, everyone? Okay. We will solve one more question regarding this type of subtract minus 90 from the sum of minus 100 and minus 50. The same thing again we will be done here. We have to subtract minus 90 from the sum of minus 100 and minus 50. First of all, we will find the sum of minus 100 and minus 50. That is minus 100 plus minus 50. What can we write? Minus 100 plus minus 50. Minus 100 minus 50 will be equal to minus 150. Now we have to subtract minus 90 from the sum of these two numbers, and as we have calculated the sum of these two numbers, the sum is 150. So we will subtract minus 90 from 150. So minus 150 minus 90. That is minus 150 minus plus 90. We can solve. That is 150 minus 90 will be equal to minus 60. This is the required answer. When we are asked to subtract minus 90 from the sum of minus 100 and minus 10, सबसे पहले हम लोग इन दोनों नंबर का सम निकालेंगे, and the sum always is plus. That is minus 100 plus minus 50. Minus 100 minus 50 will be equal to minus 150. Now we will subtract minus 90 from the sum of these two numbers. That is minus 90 will be subtracted from minus 150. Minus 150 minus 90. Minus plus 90. 150 will subtract 90. We will be left with minus 60. Is it clear? Now let's move on to one more question regarding the proof. That is the most important question. If A is equal to minus 9, B is equal to minus 6, so that A minus B is not equal to B minus A. I hope you all can remember A minus B is not equal to B minus A is for commutative law for subtraction of integer, and we had proved this thing right. I hope you all can prove it. Let's do so. If A is equal to minus 9 and B is equal to minus 7, we have to show that A minus B is equal to B minus A. Whenever we have to show anything, first of all we write LHS. In LHS we have A minus B. In RHS we have B minus A. A will be equal to minus 9 minus B will be equal to minus 6. minus 9, minus minus plus 6. Minus 9 will subtract 6, we will be left with minus 3. In RHS section, we can see B minus A. What is B? B is minus 6 minus A. What is A? A is minus 9. We will put a bracket over here. Minus 6 minus minus plus 9. 9 subtract 6, we are left with 3. What can we see? In LHS we have minus 3 and in RHS we have 3. So LHS is not equal to RHS. Hence, what was LHS? A minus B. Hence A minus B is not equal to what was RHS? B minus A. B minus A. Verified or proved. Anything can be written. Is it clear, everyone? Let's move on to one more question. That will be the last question of today's session. It is also an important question. The difference of two integer is 4. The difference of two integer is 4. The difference of two integer is 4 if one of it is minus 6, find the other. This is an important question. In this particular question, the answer can be of two types. Let's see. The difference of two integer is 4. If one of it is minus 6, let one integer be A. Then the difference of two integer, that is A minus 6 is, और द डिफरेंस ऑफ टू इंटीजर, किसी भी दो इंटीजर का डिफरेंस जो है वो 4 है. अगर उसमें से एक इंटीजर माइनस 6 है तो हमने एक इंटीजर को a मान लिया, दैट इज a माइनस 6 इज इक्वल टू 4. तो a माइनस माइनस प्लस 6 इज इक्वल टू 4. a इज इक्वल टू 4 प्लस 6 उधर जाएगा तो हो जाएगा माइनस 6. तो a इज इक्वल टू 4 माइनस 6 विल बी इक्वल टू माइनस 2. सो द वैल्यू ऑफ a will be equal to minus 2. Hence we can write, the other integer is minus 2. And we can prove this particular thing. Let us say a is equal to minus 2. We can put it over here. A is equal to minus 2 minus 6. Minus 2 minus plus 6. 6 minus 2 will be equal to 4. This is our RHS and this is also RHS. In the second step, what we can say, or we can say second method, the difference of two integer is 4. If one of them is minus 6, we can also write minus 6 minus a is equal to 4, because it is saying the difference of two integer. Minus 6 is an integer and a is also an integer, और इन दोनों का difference कितना है? 4. तो minus 6 minus a is equal to 4. Minus 6 minus plus 4 can be, इधर आ जाएगा तो हो जाएगा minus 4 is equal to minus a will be put on right side, it will be plus a. Minus 6 minus 4 is equal to minus 10. So we have a is equal to minus 10. Hence the other integer is minus 10. We can also prove this thing. Put it in first equation, that is minus 6 minus a, that is minus 10. Minus 6 minus plus 10. 10 minus 6 will be equal to 4. Hence this is true for both the case. Thus we can say the other integer can be minus 2 और 4. इन दोनों में से इंटीजर कुछ भी हो सकता है, the result will be same. The other integer can be -2 and -10. Sorry, -10. The other integer can be -2 and -10. I hope it is clear. Last, the summary. Addition of integer, subtraction of integer. Addition of integer follow closure property. Subtraction of integer also follow closure property. Addition of integer follow commutative law. Subtraction of integer do not follow commutative law. Third, addition of integer follow associative law. Do not follow associative law. Do not follow associative law. Kindly remember this particular thing. So this is the end of the live video session. You will get the homework in the SPDTG app itself. Thank you all. Have a good day.